Okay. So now we will focus on the last part of the discussion about asynchronous functions in JavaScript, and then, as you saw, next time, next Thursday, we will see a completely different topic. Okay, we start a new topic: HTTP servers, build an HTTP API servers, and so on. Which, by the way, will use asynchronous functions. Okay, so nothing gets wasted in this course. Okay. So now we're going to introduce these two keywords. Okay, that were introduced actually in ES8. Okay. So you know that the main focus is ES8. Mi chiude la porta per questo. Okay. ES8 is a more recent version of JavaScript, okay? But as I told you in the beginning, we don't really care because we have Node, which is a recent version, so it executes recent versions of the JavaScript language, much more recent than ES8. And for the browsers, all browsers supports ES6, but also support more recent version. And in any case, we will use a framework that it will convert the code in older version of JavaScript in case. So in short, we can use all the features we like from ES8 and even more recent versions of JavaScript. Okay, but the thing we want to focus on now in this remaining part of the lecture is that there are two keywords, async and await, in JavaScript that basically allows you to write promise-based asynchronous code that looks like synchronous code, and which is very useful for us because writing synchronous code, so imperative code, one instruction after the other, you wait for the previous instruction to be executed and then execute the second one and so on, is very intuitive. It's what we started programming with, okay? And but actually, we need a synchronous function because remember, JavaScript is single-threaded. If we block the execution, so if a function stays on the call stack, nothing else can be executed, okay? And the idea of having these keywords is that you just prepend, so put before a function the keyword async, and it makes this function return a promise. So it makes it an asynchronous function, okay? And you don't have to care to write, return a new promise, etc. It is done automatically. Okay, that's a good. That's the advantage of using this keyword. And the second thing is that you remember that we saw .then, .catch, pass a callback, and so on. Very nice, very JavaScript style, okay, but not so good in terms of easiness of reading code, okay? So the code is not so easy to read as easy to interpret. If we have something like await and an asynchronous function, it's immediately clear that code should stop there until you get a result from the asynchronous function that you called. And then you execute the rest of the code. But the point is that under the hood, this system uses the promises. So everything is implemented with promises that can be fulfilled or rejected. So the point is that the return value of a function called with the await can also give you a rejected promise, and you need to know it, and you need how to handle it. Okay? And we are going to see all these things now. Okay? So in short, it's very simple to use these two keywords. You define a function, and you define it with the async keyword before the function definition. This is an arrow function. You just make room for the async keyword. And then you want to use the function, you call it, and before calling it, so before the statement calling the function, you write await. Okay? But remember that since it's a function that returns a promise, it's perfectly correct to write dot then something. Okay? It's a promise. It returns a promise. That's what happens inside JavaScript. Okay? So the await will make your code wait, so stop until the promise is fulfilled or rejected. Okay, so it is settled. And so, in short, the JavaScript interpreter can also execute something else. Okay, not so important here in these very toy examples, but when you are inside the browser, when you need to react to user events and so on, it's very important that nothing too long is executed on the core stack. Otherwise, the interface becomes unresponsive. Okay, so let's see in practice how this works and how we use these keywords. The async function defines an asynchronous function, and they automatically return a promise. Okay? You have a function, you do whatever you want in terms of return value. At a certain point, you have statement and return a number, string, an object, an array, whatever you want. If you prepend this async keyword, this will be the value of the fulfilled promise returned by this function. Okay? The nice thing is that the syntax looks like a standard synchronous function. You just write async before the declaration. Okay? And the await is the keyword that you can use to wait for a promise to be settled. So, for a fulfilled or rejected promise. Okay? So, if you have a promise in pending state, the code will stop there, okay? Without blocking. So, it means that the JavaScript interpreter is free to execute something else taken from the callback queue, okay? The macro task queue, we say, and from the micro task queue as well, in case there is something, okay? So, we are blocking, but without blocking the environment. We are just stopping the code there, waiting for the promise to be settled. Okay. So, until the promise is resolved or rejected. Okay? If the promise is resolved, that is the most common case, simply the value of the resolved promise is the value of this expression with the await, and this is assigned here on the left. So this expression as a value can be simply assigned. A string, a number, but also a reference to an array, an object, whatever is valid in JavaScript is valid here. Okay? If the promise is rejected, what happens? That's an issue, right? Because expressions can only have one value in JavaScript. I mean, in many languages, but in JavaScript here, for instance. A wait expression just has one value, and the value is the value of the fulfilled promise. In case the promise is rejected, we need to distinguish the two cases. And so, the designer of this async await decided that the expression throws an exception. And you remember that we said in JavaScript there is the try catch statement available to catch exceptions. Okay? And this is the way in which you handle rejected promises with the async await system. Okay? You will have the finally as well, but I mean for later. Okay? What happens if the value of expression, so here on the right, is not a promise? Well, it doesn't give you an error. It's very simple. It's already a resolved promise. Okay? It doesn't make that much sense to use a weight on a value. Okay? But sometimes maybe you don't really know if the function is an asynchronous function or not. So if you await on something that is not an asynchronous function, it simply gives you a resolved promise. So it doesn't give you error, and you can use it without even knowing that the function was not asynchronous. Okay? So it's sort of transparent for you. Good. So let's see some examples. So we define a function that returns explicitly a promise, right? Return new promise, as we saw before in the previous 1 hour and a half. Resolve, set timeout, resolved, so a value, okay? After 2 seconds, fine. Okay. And then we define a function, async call, where we do some console log, okay? But we use await to wait for the promise to be solved. The promise returned by resolve after 2 seconds, okay? So this function does not need to be defined as async function resolve, etc. It can simply return a promise. But again, we said we can await on anything. So if the function returns a promise, it's an async function, so by definition it returns a promise. Or if it is a value, await will work. Okay? If it is a promise, it will wait for the promise to be settled, either resolved or fulfilled or rejected. Okay? Note that there is a limitation in how you can use await. Await can only be called inside asynchronous functions. Why? Because functions that use the await need to be able to stop the execution. Okay? So that's a limitation that comes together with the await. Okay? Since the function needs to be able to stop the execution, it's by definition an asynchronous function because it can stop and wait for something. Okay? And so this is a limitation that has been imposed by the designer of the language, and which is, of course, correct in terms of principles, because the functions need to be able to stop. Okay? And since it needs to be able to stop when you call it, it means that it will immediately return a promise as well, and when the promise is solved, so it means settled, fulfilled or rejected, you can attach something. And if you don't care, you simply don't attach anything and the program will finish. Okay? So let's see this example in practice. I think I have it. I mean, I should have it. Async await slide. Yes. A little bit different from the slide, but just a few more console logs. Okay? So let's test it. Async await slides. So calling, and then result, finished, end. Let's have a look at the code. Async call. Async call calls the asynchronous function. Okay? The asynchronous function, first thing is write calling. Good. That's the first thing we saw. And then result, await, resolve after 2 seconds. And this returns a promise, right? So it takes 2 seconds to solve this promise. So to fulfill this promise with a value that is resolved. Okay? Because we call resolve with a value that is a string resolved, just to do some practice. Right? So the code will stop for 2 seconds here. And then the value of this await, resolve after 2 seconds, will become resolved. okay? That is the value of the fulfilled promise. And it will be assigned on the left side of the equal sign, so the result variable, constant in this case. So then console log result will print resolved, indeed. Console log finished is a fixed string, fine. Return end. Return end, where does it go? Well, it's an asynchronous function. So what you return from an asynchronous function is the value of the fulfilled promise returned by the asynchronous function. Okay? That's why you can write here async call dot then and pass a callback, okay, that will take the value of the fulfilled promise as the parameter to be used, okay, when calling this callback. Okay? So then says, okay, console log is to be called when this promise is fulfilled. When this promise is fulfilled, it has a value, it will be end, and this end will be the first parameter to be passed to the callback passed to the then. So console log end, and that's why we get end here. Okay? Of course, we can simply ignore the value. It works anyway. Okay? Just see the result. Calling, resolved, finished. It's not mandatory to use the value of the fulfilled or rejected promise. Okay? You can simply ignore them. Okay? But maybe if you have a value and you return a value, maybe it's because you want to use it. Okay? But it's up to you. So, just practice a little bit with this code. Okay? Just try and you see how it works. Okay? Okay. So that's really nice in a certain sense because we have a statement here, a wait, and the function blocks, waits for the promise of the called function to be settled, so fulfilled or rejected. Okay? It's like making your code wait for the result of an asynchronous function. Okay? But under the hood, there are these promises going around. Okay? Good. And that's exactly the other example that we already saw in the Visual Studio Code. So, if you want from an async function, you can return a value, right? And the return value is the value of the fulfilled promise. Okay? If you want to return a rejected promise, well, it's more difficult. We say that, we only have a return value with one value. It's not so common. But in case, we say for the rejected promise, in this system async await, the rejected is handled by throwing an exception. So you need to throw something. If you throw something, or your code throws something, in an async function, it will be converted in a rejected promise. This, by the way, makes your code sometimes a little bit difficult to debug, because you have then, catch, and so on, and then there is a problem during the execution that is an error that throws an error, and this gets converted into the rejected promise. And this is something that might happen to you in the lab. In case it happens, call us and we will explain you what's happening. Okay? Okay. Handling rejected promises with await. I already told you, you handle it as an exception. Okay? So try catch, you need to have a try catch, surround the await with a try catch, and use JavaScript syntax for try catch. Catch, you define a variable, and this variable contains the exception. Okay? That is basically, in this case, the string that has been put into the rejected promise. Okay? But I think if you are a bit familiar with exceptions, sorry, you know how these things work. You just need to remember that await in case of a rejected promise throws something, and so you need to catch it somewhere. Okay? Very simple in terms of handling the exception in the code. Let me see what have. Yes, here we have the error handling, right? So node async await error handling. Okay, calling await resolve after milliseconds -1. This is the usual function where we have new promise and we say, okay, the delay is less than 0, immediately reject, otherwise set timeout. Okay? So you see, you don't wait anything, but you will see exception something, and you will not see console log result here. Because that's the usual behavior with exceptions. You know, try catch block. In case you have an exception, it stops executing the code inside the try and it jumps to the catch. Okay, so it doesn't execute the rest of the code inside the try. That's how exceptions work in general. Let's change something. Let's put 2000. Okay, let's try again. Calling resolved. Okay. So we executed this console log result, and the result is resolved because await is the value of the fulfilled promise, okay, that is determined, that is decided here, okay? And again, you can play with these examples and modify them a little bit in, you know, to create some variations of this code. Okay? Okay, good. So it seems a very theoretical discussion, but actually when you use it in practice, it becomes very useful and very easy to write. Okay? Let's have a look at this code. On the left side, you have an asynchronous function, and you recognize it because it returns a promise because you see .then here with a callback. Okay, and this is something that you will write for sure at a certain point in your web application, because you need to go to the server and ask for information. Get API data, so download some data from the server. Okay? And here you just console log, but then you will show it in the interface, whatever. If you want to wait for the result of the asynchronous function, so the get API data is an asynchronous function, with this new keyword await, you just write await get API data. That's all. You don't have to write .then and the callback, etc. We like callback because we just learned callback in JavaScript, right? So it's nice to write callbacks, but at a certain point it becomes they confuse the code, okay? Because you need to think this is a function, this is a callback, this will be called later, and so on, okay? So if you can write the code in these terms, await with a function, that's much easier to read, okay? Just remember that the surrounding function has to be async, as we said. If you don't put the async here, you will get a runtime error, okay? Because the JavaScript says I cannot execute await inside a function that is not async, okay? Of course, here, note that we didn't handle any error, so there is no try catch. But by the way, the same is true here on the left, because we don't have a catch, dot catch as well. Okay? So of course, if you want to handle errors, the code becomes more complicated, but this is true in general. Okay? But for very simple code, it might be worth, let's say, trying this way of writing with the async await, because it's much more simple to write and read. Okay? For instance, compare these two functions. Get data, get issue, then issue, get owner, then owner, send mail, etc. And always remember that these callbacks have to return a value. Don't forget it. Okay? That's a very common mistake. If you have a wait, of course, you have a return value, because you have to assign the result of the await to a variable. So you cannot forget to return a value, because the await returns a value and you assign it to something. And then you take it and you pass it as a parameter to the next function. Okay? So it is more intuitive also in these terms, okay, for the return value. Okay, so get issue, asynchronous function, so it has to be called inside an async function, okay, otherwise you get an error. And it gives you a value, and the value is the value of the fulfilled promise. And it's simply the value of the expression that you assign to the variable on the left. And then you can do whatever you want with this value. Okay? You can do console log, you can pass it to the interface in your web application, you can set it into a state as we will do in React, or you can simply use it in the next call. Okay? As it is done here. Of course, you need to know which kind of value you get. Like here, it's an object, right? Because we have this dot owner ID syntax, so for sure it's an object. Okay? But the point is that it's just a value as any other value. And the function stopped, waited for the get issue to be executed, to get a result, and then automatically resumed without us doing anything. Everything is handled by JavaScript automatically. Okay? And that's the powerfulness of this expression, this way of writing things. Okay? Okay, awaits and email, etc. Okay. So, how do you chain things with async await? Well, actually, you don't chain anything anymore. I mean, the chaining is given by the fact that you return some values, and these values are used later on in other functions. That's the chaining. I mean, it's just writing code. Okay? It's simpler to read and easier to debug, because when the function resumes, you put a breakpoint, or you put a console log on the value that you are interested in, and simply at a certain point it gets printed, and it gets printed only when you get the value, because you are awaiting on this value. Okay? If you have a promise and you want to know the value when the promise is fulfilled or rejected, you need to fill up your callbacks with code, with console log and so on. Here, you just stop on a certain line, and when you stop on that line and you have a value for a variable like users, you got the value after executing the asynchronous function. Okay? Much easier to write and much easier to debug. Okay? And this is very common, by the way. So, an asynchronous function that does a lot of asynchronous operations and waits for each asynchronous function before calling the next one, because they depend, each function depends on the previous one. Okay? So you want to wait for the result of the previous operation to do the second operation and so on. Like, look here, for instance, fetch. Fetch is just a function that we will use later on when we talk about JavaScript inside the browser. Okay? Fetch, it's available in the JavaScript API of the browser. It's a standard function in any modern browser, and actually it returns a promise. That's why we talked about promises. Well, also because we want to learn about asynchronous function, but also because there are library functions that return promises, so we need to know how to use them. One way is to use the .then syntax, and the other way is to await. Okay? Await, fetch a certain URL, and you get a response. And the response is an object, and you will see that often this object has a certain set of methods. Some methods return a promise, like this .json. It parses the JSON contained in the response or in what you fetched, okay, provided that a certain set of conditions are met, but we will talk about them later in the course. If you get a JSON response from the server, you can parse this JSON, so this format, and this JSON has been implemented inside the browsers. This JSON method has been implemented as an asynchronous function. So again, it will return a promise, and you need to await to get the actual result of the parsing. So to get an actual object you can work on, okay? Object, array, whatever it is, okay? And then it's a normal variable. You can do whatever you want depending on your code, like access. In this case, it's an array, I think. So you can access the first element and use this first element inside another fetch and so on. Okay? So you see that this code is very easy to read. So first of all, go to the server and ask for a certain URL. Get the result and wait for the result. Then, okay, we have the result. Do the JSON parsing, so the conversion from what you got inside into a JavaScript value, and wait for this result. And then do some operation. Go again to the server. Ask for something else. Wait. And then do the parsing and wait again. Okay? Very simple to write and to read as well. Okay? Of course, you can write the same stuff with a .then, and so on. But you need to be careful to write each callback correctly, remembering to return values and so on. Okay? So both syntaxes are valid. It will be up to you to decide what is better and what is not. Okay? Okay, so now we have both promises and the async await syntax. Which one we should use? Is there a recommendation given by us, I mean the teachers of the course, but in general, JavaScript programmers? Well, probably these are the four most important recommendations. They are just recommendations. You don't really need to follow them strictly, but again, as recommendations, in general, it's better to follow because they come from the experience of previous people using these functionalities. So, if the output of a certain function depends on the output of the previous one, probably this is the typical case in which the await fits best. Okay? So, you need to await the result of the previous function to perform the second function, await is the natural choice. Okay? Of course, you can write .then, etc. No problem. But probably for readability, if you don't expect errors and so on, maybe the await syntax is more clear. If functions, two or more than two functions can be run in parallel, well, maybe it's better to use promises and use the promise.all method that we saw before. Okay? Because, I mean, there's no real alternative to await for two asynchronous functions at the same time. I cannot really write await function 1, function 2. There's no syntax like this. Maybe in the future they introduce it. But for the moment, there's no alternative. Okay? So, if functions need to be executed in parallel, probably you have no alternative than using promises and forgetting about the await. Okay? And other two recommendations. Try not to create huge async functions with many awaits inside the function. Okay? Just because, every time you stop on an await, this function will stop. Okay? Good. Here it stayed. And so it becomes, I mean, like functions like this. I mean, it's not forbidden, but I mean, they are not blocking JavaScript code, okay, other JavaScript code, because every time you reach an await, you allow other code to be executed, okay, because you're running an asynchronous function. And then when it finishes, it goes back inside the micro task queue, okay? And if something else is being done, it waits. But of course, I mean, if you fill up a function of awaits, then it becomes difficult to handle, to understand when it finishes, how long it takes, and so on, okay? So maybe it's better to encapsulate single functionalities inside smaller asynchronous functions, okay? And if your code, last recommendation, if your code contains blocking code, okay, it is better to make it an async function, okay? So, let's say you have a library that makes synchronous access to the database, which is, by the way, included in Node. And we don't want to use it because it's better to think in terms of async functions. If you use it, basically, you block everything until you get the result, right? But nowadays, you know how to make them async functions. Return new promise. Or just make the function async, okay? What's the advantage of making a function that contains blocking code asynchronous? The advantage is that when you call it, you can decide what to do. You want to await, you just put await in front, okay? And then you will wait. You don't want to wait, you make it return a promise, you attach something, .then and so on, and you use it, and you continue with your code, okay? So basically, who calls the function can decide the level of asynchronicity they want, okay? So you want to call it synchronously, you await and you don't do anything else. You want to call it asynchronously, okay, you call it, you get a promise, and you attach something to the promise, and then you do something else. Okay? It's up to you. It's up to the caller to decide what to do. Okay? So it gives more flexibility to the ones that are using your code. Okay, so these are the recommendations that we give to for using promises or async await. Okay, so don't be afraid of using await, it's fine, and don't be afraid of using promises. Okay, every condition has its own best way, let's say, to be coded in terms of promises or async await. So let's go back to our examples. So you remember that we had these two functions, insert one, that is insert a new value into a row of a table called numbers, okay, in column number, and then print count goes in the database, select count star as taught from number, so basically it counts the number of rows. Okay? So, do we want to make the these functions asynchronous? It's easy, right? Return a new promise, resolve reject, and then db run. You remember that we have a callback, and this cannot be changed because the library decided that run takes a callback, okay? But inside the callback, we can then call resolve or reject when we finished, okay? And we don't have to write additional code inside here. So if there is an error, typically you reject, so you return a rejected promise with the error value. So you know what happened. So you can do console log, whatever you want outside. Else, resolve, and actually with the insert you don't have so much things to return, right? So this is just a fixed string. With the db all, you have a callback error rows, and since it's a select, there is a second parameter, this rows, that contains the result of the query. So if error reject error, no problem. Else, okay, console log, we don't care the console log at the moment. But then resolve rows 0 dot, because it returns an array of rows. Okay, it's db all, not db get. So it takes the first row and takes the field named dot. Okay, because we called it dot in the query. Okay. If you are unsure in the lab, I mean, just print the whole object, just the console log rows, have a look at how it is built, and then you adjust the code and you write the name of the properties you're interested in and so on. Okay? Very, very simple. But, so we have insert one and print count as two asynchronous functions. And now we can decide how to use them. And with the await, it's actually very, very simple. You see, so there's a loop 100 times, just await, 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 await. That's what you wanted in the beginning, right? So actually we wanted to do an insert and count, insert and count, insert and count. And we started from a condition where we had callbacks and we didn't know where to put the code. We passed through a situation in which we had promises, but basically we had to create a chain of promises, 100, actually 200, because there are two operations for each cycle in the loop, 200 callbacks attached, one to the other, 200 promises. And now we have a much simpler code because we just have await, okay? Actually, we don't really care about the result, okay? We don't use anything here on the left side of your await. As any JavaScript expression, I mean, if you just want to ignore it, okay? We don't have to write const a equal to await insert one, okay? Maybe you wanted to write const num equal to await print count. That's possible, and then console log num. fine. Actually, just to make this code shorter, we did the console log here, okay? But it's actually the same. You can modify the code and see if it works in this way as well. And then, when the loop finishes, well, just close the DB, no problem. You are sure that you already executed all the queries. Why? Because the await makes you wait for the asynchronous operation to finish. Okay? So, we started from a very difficult, let's say, code to execute these 200 queries, and we ended up with something very simple and easy to read, right? Here you see the difference. Await versus the then, so the promises approach. Actually, on the left side, you have promises as well. You just ignore, you don't attach anything to the fulfilled promise, okay? Because it's a JavaScript interpreter that automatically knows that, I mean, you don't care about the value of the fulfilled promise, and it goes on and executes the next instruction. Okay? Here, instead, to make you wait for the result, we need to put something into the then, so to attach something to the promise with the then method so that it is executed just when the promise is solved. Okay? So you see that this code on the right is still more difficult than the one on the left. Okay? That's why they introduced async await, because it makes this code much easier to write and to read. Okay? Just be careful of the fact that here you cannot simply write db close as you do here on the left, because the db close is the operation that must be done at the end, right? So it's the last operation to be done, and so it must be put into a callback that is attached to the last fulfilled promise. Okay? So p then, and p basically it's a variable that when you loop inside here this cycle, basically it always contains the last promise that has been created by the then. Okay? And so the last promise, you attach the db close and it's fine. Okay? If you put db close without the p then, basically you close the database before some queries are executed. So some queries will give you error because the database is already closed. Okay, so beware of the bug, and then we will try a little bit of code since we have time. So, which version is the correct one? I hope now it's clear. Hopefully, left or right? We should do the polling. You know, the teaching lab says you should do polling during the classroom and so on. So, who is in favor of the left one? Left, 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 left or right? And who is in favor of the right one? Nobody, the other are sleeping. Anyway, the left one is the correct one, right? Because you need to execute the db close after all the awaits. If you put it here, main, after the main, okay? Remember, the main calls an async function. It immediately returns. It returns a promise, which is not fulfilled or rejected until all the code inside the async function has been executed. Okay? So, this main is a promise. This promise will be settled only when the async function will return. It returns nothing, so it returns undefined. It will be fulfilled with the undefined value, but we don't care because we don't need to print it, right? We don't have a value. But the right one is wrong. Why? Because the main calls the async function. The async function, the first thing it does, it returns a promise, and it's finished. Okay? And this promise is not settled yet. No problem. Code goes on. So execution goes on. JavaScript goes to and execute db close. I close the db before all these insert and print are executed, so it doesn't work. Okay? Good. Let's try. So you can say play a little bit with this code and understand this async, await, promises, and so on. So queries, I think it's query promises. No, that's the await. Yes, I made everything. I put everything together, right? So here. Is it promise? No. Yeah. What is promises? Okay. So you saw the code here. This code is the one with the promises. P then, and so on, and P always contains the last promise. Okay? So let's try to execute it, main 2, right? And of course, insert 1, print count, we saw them before. They are just return new promise and so on. Okay? The same on the slide. So node db node queries promises. You see the numbers, and you see they are perfectly in order because you do the insert and you do the count. You do the insert and you do the count, and when you do the count, you already did the insert because you are in the callback of the then of the promise that have done the insert. Okay? So you change all the operations and you wait for the previous operation to finish to do the second operation. Okay? Good. Now I cannot move in the middle. How can I move it? Okay. Let's change things. Let's call main. Okay. So main is the await version. Okay. Actually, it will work the same. Let's try. You see the numbers again. They are perfectly in order. Why? Because the await waits for the previous function to finish, for the promise to settle. Okay? So insert 1, print count. Insert 1, print count. Okay? You want to test what we saw on the slides? So db close, if we put the db close here, save. Okay, you can do these experiments. You see, well, actually, we close the database before executing the first query, actually, right? So basically, we do nothing. And by the way, it's nice to see what happens, right? So db close, okay, we close the db. And then there are asynchronous methods to be executed, right? So there is the insert one that is called here by the await. Oops. And this is a rejected promise. And remember, we didn't handle the rejected promise. You handle the rejected promise with a try catch, but we didn't use the try catch. So what happens? Well, it happens the same as what happens in any language that has exception and you don't handle exceptions. The exception goes up inside in the call stack, actually down in the call stack until you reach the main program, right? The main program level. So, and nobody catches the exception, and so the system, the interpreter, catches the exception and stops the program. Okay? And typically it prints the value of the exception. Okay? And the SQLite3 library is nice in this, in how to write these errors, okay, and it tells us basically the database handler is closed, okay, and that's why this message comes out. It's simply an exception that has been not caught at any level, okay. If you put a try catch around the await in the catch, you can catch this exception. But then what can you do? I mean, typically you do console log. If you don't expect the exception in normal program operations, I mean, you can just print it and typically it's a bug inside your program, right? Okay. I mean, okay, we should fix the bug, right? So db close, Zia, right? db close. Save and try again. No, I didn't save. Remember to save the file. This happens in the lab as well, okay? And the same happens for main2, right? db close. And main2. That's the same problem. Okay? By the way, it happens the same also with the promises. db close, yeah, basically, no, sorry, not the db close. The callback, okay, the first callback, first promise is resolved, no problem. But the second, I mean, the callback attached to the first promise that is resolved will throw an exception, okay? Yeah, insert one. No, actually, it will reject the promise. Let's see. It rejects, okay? It will create a rejected promise. And then, you see, we don't have any p.catch. We should have written something like p.catch and so on, okay? That's the same, yeah. That's the same as doing the try catch in the await case, okay? A rejected promise needs to be caught somewhere at a certain point, okay? Otherwise, it gives you the same result as an exception. Nobody catches the rejected promise, and this bubbles up, okay, until somebody catches it. If nobody catches it, it will create, it will stop the program, okay? Okay, we can remove this, I think. Okay, no, let me, yeah, db close is wrong, right? And let me go back, hopefully, yes, to the correct code. Okay, yes. So final thing I want to tell you. So there are various options for using SQLite libraries. We saw this SQLite 3, that is the basic SQLite interface. And actually, even though we saw, you know, it's not well maintained anymore, unfortunately. And so maybe for next year we will do something different, but for this year it's fine to use it. Also for the exams, okay? If it's a library that we suggested, of course at the exam we don't complain, right? But we like it very, very much because it has this possibility to pass a callback that will be called asynchronously. So from the teaching point of view, it's very good, okay? Because now we learned about asynchronous callbacks, and also in a situation that we will use a lot in next weeks, okay? But just be aware of the fact that there are other libraries available as well, okay, to handle SQLite. This SQLite actually is the same as SQLite 3, but just automatically return ES6 promises. So basically, sort of a wrapper around all the functions you already saw, and all of them already have a return new promise. Okay? Of course, they defined some behavior in case there are errors, so they will decide what to put inside the rejected promise if it is written in the library. Okay? Written in TypeScript, we don't care. Another asynchronous library returns a promise. It has a promise-based interface and so on. There are also synchronous APIs, but I would recommend you not to use them. Okay? There is a synchronous API inside the node as well to handle SQLite. But again, if it's asynchronous, it's blocking, and we don't really have a way to avoid blocking in this case. And since basically we are using the SQLite on the server side, and next time we will write some code on the server side, and the server must not be blocked by a single request, okay? Must be able to accept other requests while it's processing one, because it's accessing the database file and so on. We don't want to use synchronous interfaces. That's why it's grayed out, okay? And of course, you're free to search the NPM registry. I have no idea of all the other libraries that are here around. But, I mean, for the purpose of this course, for us, it's fine if you use the SQLite 3, okay? Just be aware of the fact that depending on what you need to do, there might be alternatives that might be more suitable for your case. And of course, once you go to program something that is not for just a toy example for this course, but something more bigger and so on, maybe you don't want to use SQLite 3, which is just a file for a database, but you want to use a real database server and search for a package with all the characteristics that we discussed last week, okay? Just it's well supported, well tested, with a good community, it addresses bugs quickly, and somebody has to check the code, okay? But this is another story, okay? Let me think if I still need to tell you something. So for the lab, tomorrow there is lab for the 2 groups, and Thursday the 3rd group. I wanted to show you the text of the lab. Okay, see, this is the text for the lab for tomorrow and Thursday. You need to play a little bit with the with databases and promises. Promises, async and await. Okay, they are all the same thing. And so we ask you to write some SQL code, call some SQL code, and use implement actually functions that returns a promise that resolves to a certain value, that is the value you want to return from your functions. Okay? You already find the code, but it's written in the text. Okay? So at the end you have all the instructions, the link and so on. And you already find the database and the SQL code needed to create a database in case you want to change something here in the folder. And after the labs, we will publish a proposed solution, so our proposed solution. Okay? As in any programming assignment, there is not just a single solution. Of course, there are bad and good solutions, and if you are unsure, just use the lab to ask us. Okay? This is good, this is bad, could it have been better, is it acceptable, what are the limitations, and so on. Just use the time that you have in the lab to, let's say, to in the best way that is convenient for you. You need some help on something that we saw during the lectures. You need some advice on how to improve your code. You want to understand the advantages or disadvantages of doing in a certain way rather than another, and so on. Feel free to ask whatever you want during the labs. Okay? I think I have nothing more for today, so a bit shorter than what I expected, but I think it's fine unless you have any questions. I think we can finish here. We started on time at 2:30, so I mean, more or less, everything has been done. Okay? So I don't see any questions, so I think it's all for today. And we will meet tomorrow in the lab for the 2 groups scheduled for tomorrow, and then Thursday, well, we have lecture, and then for the 3rd group of the lab. Okay, thank you.